An octave sounds like somewhere from Over the Rainbow. See if you can pick out the octaves in this music. Somewhere over, somewhere. These are all octaves, doublings of frequencies. In music, when one note has twice the frequency of the other, we hear it as an octave higher.
Half the length of the longest one. Half the length, twice the frequency, one octave higher. The lute. Every fawn has one around the house. Now, take a string, cut it the length in half. Twice the frequency, as before. One octave higher. Are you paying attention?
The high note has twice the frequency of the lower note, just as one orbit has twice the frequency of the other. We see this 2-to-1 ratio in many orbital systems, such as the moons of Jupiter, Io, Europa, and Ganymede. The moon Mimas orbits Saturn with twice the frequency of particles in a certain region of Saturn's rings. And in fact, this is what causes the gap. Mimas pulls on those particles right out of the gap. Bum 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 ba-da-dum, bum bum. Another very common and very pleasing interval we hear often in music is where a higher note is 1.5 times the frequency of the lower note. Now, to get this, we cut the string to 2/3 of its original length. That gives us 3/2 times the frequency. This sounds like a very harmonious, perfect fifth in music. Then again, cut the string to 2/3 its previous length. Repeating this generates a circle of fifths. This generates all 12 notes of the scale, but they get higher and higher. Likewise, you can cut pipes to 2/3 or 3/4 its original length, and you get these same harmonious intervals, a perfect fourth and a perfect fifth. We see this 3-to-2 ratio of frequencies in our solar system. Neptune has 3/2 the orbital frequency of Pluto, just like a perfect fifth. So there is a heavenly harmony, what the ancients called the music of the spheres.